Kia ora Year 13 and Year 12. This is a video going through implicit differentiation, which is what I'm going to be doing in class tomorrow on Monday. But I already know that there are going to be some of you away. So far I think we're up to 4 people being away, so I thought I'd try and record it. Implicit differentiation is one of the most useful techniques in differentiation for solving harder problems, and hopefully this video is going to show you the basic ideas of how it works. You need to be quite confident with the product rule and the chain rule to get using it in harder problems, but the one I'm going to start off with is one where we really don't need to use this cool new method. So I thought I'd start with a curve that was a bit different from the usual one that I start with, which is this weird shaped thing on the front slide, and this has got the following equation: x squared plus y cubed is equal to 5. So you can see that there's obviously a link between x and y, right? And that's the case whenever we have an ordinary old function. So if we've got y is equal to 2x plus 3, there's a link between x and y, right? We take an x, we put it into our function machine, and out pops the y. When we're doing implicit differentiation, it's usually because we can't see that link as clearly. But the two that I'm going to start with are ones where we can always do what we used to do and make y the subject. So we're going to look at how we would find the slope of the curve using our old methods first. So let's take it and rewrite it as y cubed is equal to negative x squared plus 5. What can I do now? Well, if I take the cube root on each side, this is what I get. Y equals negative x squared plus 5 to the power of 1/3. I can differentiate that using the chain rule. Dy by dx will be 1/3 of negative x squared plus 5 to the power of negative 2/3 times the derivative of the inside function, which is negative 2x. So cleaning that up, this is what we get. We get negative 2x over 3, and then we've got this. And if I said to you, I want you to tell me, whoops, sorry about that. If I said, tell me the slope of the curve at x equals 0, you would substitute it in, and you'd get negative 2 times 0 over 3 times root of 25, okay, which is just 0. And that fits with this lovely curvy picture here perfectly, okay? But that was already a little bit of painful differentiation, and we can do this a whole different way. But we have to think about functions and the links between x and y completely differently from what we're used to. So we usually think of x as the input and y as the output. But when we're solving problems that require us to use implicit differentiation, the idea, well, this is how I think about it. We think about y and x having a link, but a link that sometimes is really hard to disentangle. However, I'm going to start off by doing this one where it's not really hard to disentangle. So let's go back to the first question we had and look at a different way to solve this problem. What I want you to do is to think about y as a function of x. So y somehow depends on x. And that means that we can use the chain rule as follows. So I'm just going to do this question and you're going to get the idea from that. Let's differentiate x squared with respect to x. Well, we get 2x. Now let's think about how we can differentiate the y cubed with respect to x. Well, we can't differentiate it with respect to x because the variable in here is y. But we can differentiate it with respect to y and then use the chain rule to finish it off. So we've now taken y cubed and we've figured out the link between a small change in x dx and what will happen to y cubed. Lastly, we say, well, what happens when I differentiate 5 with respect to x? This is a constant, so this will become 0. So we've just kind of done our first implicit differentiation thing. So cleaning that up, what do we get? Well, we get 2x plus 3y squared times dy by dx is equal to 0. So sometimes we call that a first order condition. we actually do that more in economics than in maths, but it's a useful idea. It means we've done the differentiation, and now we've got a choice for what to do next. Suppose you're asked to find the derivative at x equals 0. Well, I can do one of two things. I can go on and get an expression now for dy by dx. So let's do that. dy by dx is equal to negative 2x divided by 3y squared. Now, the lovely thing about that is that all I need to know is my x value and my y value. So, if I want to find dy by dx at x equals 0, I just have to work out what y is. Right? And my curve was x squared plus y cubed is equal to 5. So, we get 0 plus y cubed is 5. Y is equal to the cube root of 5. Now I substitute the x and the y into here, and I get dy by dx is equal to negative 2 times 0 over 3 times the cube root of 5 squared, which is equal to 0. Obviously I'm going to get the same answer that I did when I did it our old-fashioned way. Right, so the first way that I did this one, just to go over it, is I made y the subject. Right, so we made y the subject, and then we differentiated as usual. But the second way was to do this weird thing called implicit. And when we're doing implicit, we think of y as a function of x, and we use the chain rule. So let's do another one that's a much more familiar example. So here we've got the equation of a circle. X squared plus y squared is equal to 25. So here's the picture here. And if I said that I want to find the slope of the tangent to that curve when x equals 2, you can see that there are actually two values here. Right? So just grabbing the ruler and putting it on approximately. So I suppose I could have done this all in GeoGebra. There's my first tangent, right? And down here, here's my second tangent. Okay? So how can we do that by making y the subject? Well, we can say y squared is equal to plus or minus root 25 minus x squared. And we need to take, y is equal to plus or minus root 25 minus x squared. We have to look at each of those semicircles in turn. So let's do the first one as the positive, which is this one here. Y is equal to 25 minus x squared to the power of a half. dy by dx, again it's a big pain, it's going to be 1/2 25 minus x squared to the negative a half times negative 2x. Now if you're not liking that, that means you haven't done enough chain rule practice yet. Okay, so go have a look at the EP that I sent you. Ethan and Kieran, I've seen you guys just about finished the first bit already, so well done. So here I've got my expression in the usual way for dy by dx, and if I want to figure out the slope at x equals 2, I go and I substitute in x equals 2, and I get negative 2 over the square root of 25 minus 4, which is 21. And that works out to be, what's that going to be? I don't know, negative 2 over 4 point something. Right, so we should look at that and go, well, it should be roughly negative a half. Yep, that looks good. Right, you can see here, slope is around negative a half. And then I have to go and do the thing again for the bottom half. Right, so the other one will have a negative in front of it. But let's now do this using implicit differentiation, and you'll see how easy it is. So we've got x squared plus y squared is equal to 25. And instead of making it y equals something, we're just going to think that the y changes when the x changes. So we go ahead and we differentiate with respect to x. And we're going to write that like this. So we're differentiating the x squared with respect to x. And then we're differentiating the y squared with respect to x, and we're differentiating the constant with respect to x. So here we're going to get 2x plus Well, we can't differentiate y squared with respect to x. We have to differentiate it with respect to y. But then we chain rule it by saying that we know that the x affects the y like this, and we know exactly how a change in y affects y squared. And so that equals 0. What does that give me? Well, I get 2x plus 2y dy by dx equals 0. So now I want to know when x equals 2, what's dy by dx? We can use this directly to work that out. We know that when x squared plus y squared equals 25 and x equals 2, y is equal to plus or minus root 21, right? So thinking about the circle, I've got one value up here, that's root 21, and one value down here, which is negative root 21. So my two answers here are going to be 4 plus 2 root 21 dy by dx is equal to 0. So I can now go on and solve it. I guess I could have just done that to start with. Dy by dx here will equal negative 4 over 2 root 21, which is negative 2 over root 21, which is exactly what we got up there. And I can do the same thing for y equals negative root 21. So substituting in here, I'm going to have x as 2 again, but this time my y will be the negative value. So we get 4 minus 2 root 21 dy by dx equals 0, giving me dy by dx is equal to negative 4 over negative 2 root 21, which is 2 over root 21. Now go back and look at the graph, see if it works, and yes it does, it works beautifully because I'm here, right? So I've got a positive, pretty low, but a positive value of the slope. Okay, so that's the basic idea of how implicit differentiation works. I'm going to give you one more to try on your own, and I'm going to do a second video with some much cooler curves and some much more realistic problems. So I want you to try, let's think of one, x cubed plus 2y minus y cubed equals 1. So I want you to differentiate that and just get an expression for dy by dx. So pause the video and have a go at that question. Okay, so here's what you should have got. 3x squared plus 2 times dy by dx minus 3y squared dy by dx is equal to 0. I'm going to collect up like terms. Now I'm going to collect up the stuff with dy by dx, and I'm going to have 2 minus 3y squared, and lastly dy by dx will equal negative 3x squared over 2 minus 3y squared. Okay, so that's the last one that we're going to do for a while, where all of the x's and y's are separated out. Once we start to have them together, we're going to have to be doing implicit and chain rule and product rule together. So hold on to your hats, and if you need to do some practice on product rule and chain rule, you better go do that before you watch video 2. Thanks for watching. I know some of you guys are so sitting there looking at the video as soon as it comes up, so if you watch this before class tomorrow, that's fantastic. That'll mean that you can start getting on with the textbook practice, but this is the main thing that I'll be teaching in class tomorrow. So if you're going to be away, this is the first half of what you're going to miss.